Class 2 is going to be all about setting up your host application and setting up your mix for the process of working, right? So, in other words, one of the things we're going to talk about is the mixed signal flow, right? And so, with mixed signal flow, what I'm really getting at here is just something simple, right? Which is that audio. When we have audio, we'll have a certain audio tracks, right? We'll have audio tracks. Nothing surprising there. And so what happens, where does that audio path go through? And how do we route audio, right? And what is the mixed signal flow? So normally in an analog console, what you would have to start off with is you would have some form of a preamp, right? Usually a line preamp, right? And so that line amp would allow you to control the gain of the signal coming from the multitrack, right? So in other words, if we had an analog tape machine, right? And let's just start from there, right? And the tracks coming off the analog tape machine, however many you had, say you had 24, each one would go into a separate line input. And then from that line input, you would go through different levels of processing. For example, you might have filters, right? That would be filtering high and low frequencies. This would allow you to get rid of rumble, right? And this would allow you to get rid of hiss and noises that you would want to get rid of, right? So you'd have some filters, high pass and low pass filters. You might go through some dynamics processing, right? Which would be compression and gating, right? And that would allow you to control the sound from a dynamic perspective. We would then go through equalization, right? So the EQ, 3-band, 4-band, whatever it is, would allow us to control the overall tonal balance, right? The balance of frequencies. And then from there, we would go down into a mix fader, and this would allow us to control the overall gain, right, of the signal. We would run through a pan pot, right, and that pan pot would allow us to move the signal between the left side and the right side. So all these things would manipulate the audio signal. It would go into a pan pot, and then it would go into a left-right mix, right? So in terms of our stereo mix, we would have a single fader that has a left and right signal, right? And the signal would go into that stereo fader, and this is what would be feeding our speakers, right? In terms of what we're listening to. And this would also be feeding our 2-track, right? So if we were actually recording in an old analog studio, we'd have a 2-track analog tape machine, right? So this is our multi-track up here, and this is our 2-track here for our final mix. Okay, so the audio signal, all the individual tracks go in through a gain stage, through different forms of processing, through a level control, through a pan pot, which allows us to take the signal and divide it over the stereo spectrum. And then it goes through a master fader. So all of these levels and pan pots of all the individual tracks, right, that come in and end up in the individual faders, right, that you see here, get all blended together, right, through a master output. Okay, and that's the basics of the signal flow. So let's translate this into the world of digital. So the difference is that now instead of a multi-track, we have a hard drive or a series of hard drives, and those signals, right now, all in the digital realm, right now come into a virtual interface, and the way that this is set up is that the primary thing that'll happen is it'll basically go through some form of a track, right? So you'll see the track displayed as regions or clips, right? You'll see a waveform display, right? And that waveform display then will feed into a series of inserts, right? So you'll have a series of inserts, and those inserts will allow you to apply all the same types of processing, right? So we could apply equalization, we could apply dynamics, compressors and gates, right? We can apply reverberation or effects like that if we wanted to put it. Generally, you don't do that on inserts, but sometimes, okay? We then go into a fader, right? And this fader then goes to a pan pot, right? And into our stereo mix, right? And eventually through a master fader. So a similar thing, but because this is all virtual, we have the ability to move things around, right, without limitation. We also have effect sends, right? And our sends typically feed after our fader, and sometimes if they're fed stereo post pan pot, right, you can determine that whether it's pre or post. And those things would generally feed into reverbs, right? And those reverbs would come back into other returns, which would also go through pan pots, and then get mixed into our mix bus. Okay, so simple, right? So instead of them coming from a multi-track, right, they're basically going through a track display, which is defining what information we need to gather from the hard drive. So it's no longer linear, and it goes through some different stages of processing, and then we can apply effects through sends. We could do that in the analog realm as well. That's where it comes from. And it goes through a master fader, right? And that master fader then would print an output mix that would go back to a hard drive, right? So that would spit out the 2-track result, bounced down into stereo. And that's what we would send off to people. Okay, so no mystery there, right? No mystery there. Pretty simple, pretty straightforward. So when I actually designed this course, there's some things that engineers would do. And as analog technology developed, there were some interesting things that came up. And one of the things was that one of the big technological differences that was added in with the consoles of the 90s in particular is that consoles, instead of just having a left and right bus, would also have a series of 4 additional stereo buses. So let's just call them A, B, C, and D. And these stereo buses, right, these individual stereo buses could then be assigned to different locations. So in many cases, what would happen is these stereo buses that you could feed to, instead of feeding to the left, right. So now all of a sudden, if you have your fader and it goes into a pan pot, you have an assignment panel. And you could say, I want this to go into bus A instead of going into the left and right bus. And now what would happen is it goes into this submix, or what would be called a stem, right? And so these are stems. Now, what these were primarily used for was for surround mixing. So stem A could go the left-right. Stem B could feed your center speaker and sub. Send C could feed your surround speakers, right, to the rear. And send D could feed, if you're doing 7.1, your LE, RE, right? So the left extended extra, right extra, right, which sort of side fill speakers. And you could assign these to individual outputs that way. But instead, what engineers did was they assigned these back into the left-right. And what it gave you the ability to do, right, was the ability to say, put all of my drums, right? So let me just say, for example, let me just do a little editing here, right, on this, right? And then, so let's just say that our initial stem A is all of our drums and percussion. And stem B is all of our music, right, with effects. So these are all the instrumentations that we have, guitars, piano, bass, any kind of keys, things like that. And then we have, say, another mix of, could either be like, maybe you have a horn section, right? So let's just say that these are our horn section, right? That we want to separate or process independently. Or it could be background vocals with effects. Or we could have then a mix of vocals, right? And so what would happen is it would give us the ability to take all of the drums as a stereo mix and process them independent of the other things. So now it gives us the ability, for example, to process, let's just say I have a drum kit here, right? And let's just say my drum kit, I'm just going to have 4 mics, right? I have a kick drum, a snare drum, a hi-hat, and some overheads. And not overhead. So now I could process these with individual levels of EQ, compression, right, for each of the individual instruments. And then these would get fed into a stem, and this stem could then be equalized as a whole, compressed as a whole. And what that does is it, with the effects, right, so all the effects and the dry instruments get fed into the stem, and then I could put a compressor right across the stem of the drums and equalize and compress the drums so that it actually, the sound really pulls together and solidifies and sounds like an instrument, and then goes off into the mix bus. So if I do that with all the individual groupings of instruments, right, where I could do that type of processing, then I have 3 tiers of processing. I have the individual processing, right? I have the stem level of processing, right, which is here, right, the stems. And all of those, let's just say I go into my master fader over here, right? So this is my master fader, my output of the stereo mix. I now have the ability to also compress and equalize my stereo mix. So I have 3 levels of processing set up. So if I just quickly slide over to a mix session, one of the things that I talk about in terms of setting up my session here is that here you could see that I've color-coded tracks, right? So I have all of these audio tracks, and so each of the individual instruments, like the bass and all the drums and percussion, have similar colors, and the effects, right, for those individual drums are also together. I have them all highlighted in like a turquoise color, and they're all bussed out to a bus 1 2, right, which is like our stem A. And then that comes into a separate fader here, right, which has all of the drums. So this is my entire mix of drums, which I can then compress and equalize and process on the way into my master fader, so that now I can process signals on the master fader as well, right? So this gives me a whole new level of different ways to work with the sound, right? Because now I can have individual audio tracks. I can process them with EQs and compression and all that sort of stuff. I can then feed them to effects processors, which then get bussed into the same channels, right? The same stem. And so I have the individual controls of the sounds, and then I can sort of glue all of those together in the second level, in the second tier. And then as I take those individual stems, I can bus them together. And this structure is really important because it makes everything brilliantly easy, right, in terms of processing. Now the ability to actually create stems, you can create a load of mixes just by hitting your mute buttons. I can create just a drums and percussion mix. I can create a music mix, all the music with drums and percussion and no vocals. I can have it with just the background vocals and along with the drums and music. And now I have what's called a TV track, which allows the vocalist, the lead vocalist, to sing over the top of it, right? So quite often when an artist performs on television and they don't bring a band, they can go out with a single microphone and they're basically singing to the 2-track mix from the record, right? And they just sing live to it. You could have a cappella versions. You could have a mix that just has the vocals in it, right? Mixed with just the background vocals. And these things are important for movies, right? So if you get a song in a movie, they're going to want to have mix stems. So it's incredibly easy, right, to set up these individual forms of mixing, right, and processing, right? So it's very clean and simple. So this whole structure of mixing, the way I organize the tracks, right, the way that I set them up and stage them, pair them together, color code them, lay them out, is really important. These visuals keep you from making mistakes, right? Because when you have your vocals and the harmony vocals side by side, and they're processed side by side and they're the same color, when you look at them, you get into this habit. I know that the vocals are always red. I know that my piano and keyboard tracks are always orange, right? I know my guitar tracks are always blue, right? Etc. My acoustic instrument, stringed instrument tracks are all green, right? My drums are always this color brown. It creates a basic flow to your session, right? Which is very powerful. So those visual elements are great because they give you cues that keep you organized, right? And for the amount of time that it takes you to set this up, you save that tenfold over the course of the mix. Because most people look, it's like, I don't want to spend the time to do that, right? And actually, if they did that, it would save them hours through the mixing process, just spending that extra 10 minutes to set that up. And so I talk about that, and it's really important, right? So what you're really doing is you're putting yourself in the best position to succeed, right? So that's the whole 3-tiered mixing system. And then I'm going to really get into talking about how you set a goal for your mix. So when you start to put together your mix, most of the time that song was written and inspired by different artists, right? Maybe the artist is trying to emulate, maybe they're trying to be like Nirvana, right? Big Kurt Cobain fan, and I want to be the next Nirvana, right? And so they write songs and they really love that sound from Nevermind, and that's kind of what they're going for this particular record. And maybe they have their own twist on it, but they go into that. So what they're really doing is you want to have like a template that you're following, something that you can reference to, that you can listen to, that you really love, which is really exciting and a great song that you can reference to, not to copy it, okay, but to try to match the energy. You want your mix to match the energy of what it is that you're hearing from this artist. And of course, you're comparing yourself to professionals. So what this does is that it it will become very obvious where your mix is deficient, right? So in other words, if you're lacking the presence, right, in your mix by comparison to what's there, and you compare the two of them while you're working, right, you'll hear that difference and you'll be more aggressive with your approach to mixing. Really important. So that setting a goal, right, and determining what kind of sound you're going for is really critical, right? And so part of this is also going to be, and we're going to talk about this. So this actually kind of goes back into week one, it's just doing the mix mapping, right? And the mix mapping is where what you do essentially is you start by let's see if I can scroll down here for a second. The mix mapping worksheet, which is something you can download, that's available on one of the lessons on the website. You list instrumentation. You list the levels. So this is about analyzing existing mixes of artists that you really like. You put the pan position of those individual instruments. You define how compressed the signal is. You do an equalization curve. So it's not like you write down what frequencies exist, but you could do kind of a graph that goes across, right, that shows the basic frequency shape as you hear it. The important thing to understand is that when you fill out this mix mapping worksheet, right, and you're studying mixes that you really love. So like say for example, we picked a mix that we're using as a template, right, as a reference for this particular mix. The first thing you should do is do a mix map of it, right? So write down all the instrumentation you hear. The relative levels. So the loudest thing is the vocal, that's a 10. Right? The second loudest thing is the kick drum, that's a 9.5. Or maybe it's a 10, maybe it's just as loud as the vocal, right? And you list your instrumentation in terms of relative level. Where are those instruments panned? How compressed do they sound? What is the basic equalization shape, right? What effects do you hear? I hear reverbs, I hear delays. So when you first start, it's going to be very basic stuff like that. The more you start mixing and doing this, you're going to say that effect is not just a reverb, it's a plate reverb. It's a plate reverb with 30 milliseconds of pre-delay, right? And it's, 1.2 seconds reverb time. And you laugh probably, you're listening to this and thinking like, am I going to be able to hear that? Yes, you will, because you'll start to do things and you'll call up a reverb and you'll say, God, it sounds exactly like the effect from this record, right? And then you'll get all of these things that will come up, right, over the course. So this is important. So this what I'm asking, or what I'm talking about here is studying the art of mixing, right? It doesn't just happen, right? It's something that you have to work at, right? Nobody picks up an instrument and just starts playing the instrument without really studying anything about what it's about, right? You have to listen to artists who play that particular instrument. You have to try to emulate them, try to transcribe those performances, try to emulate that, right? And so what you're doing is you're listening, right? And you're working on your technique and your dexterity with your instrument, right? Your facility with it, your ability to hear and pull out notes, your ability to transcribe and emulate what you hear and translate that to your fingers when you play the instrument. And so you would study and you would work and you would work and you'd study and you'd work hard to be good at playing an instrument. And being a mix engineer is no different. When you listen to a mix, you want to be able to dissect it. You want to be able to transcribe that mix. So instead of putting this on sheet music, right, and trying to transcribe the actual notes, you're transcribing the technical mixing engineering elements of that mix, right? Same basic idea, right? And so those of you guys who are musicians, many of you guys are musicians, and if you studied music and you understand that, you've gone through that process, right? And so now it's a matter of translating that. And the sooner you embrace this, I'll tell you, you do this and your mixing chops will just explode. They will just you will just learn so fast doing this. It's amazing, right? And it's like one of those things, oh, I don't want to do that, right? When you actually sit down and you do it, and the more that you do it, the faster you will learn. It will just explode the process and the speed and your facility with mixing. The next thing is, beyond the mix mapping, is getting on to mapping the perspective, right? In other words, you actually draw where you hear the instruments. I hear the vocal up here, right? So if I was doing this, I might, pick different colors for the different instruments, and maybe I'll do something here and I'll say, I hear my vocal over here, right? And I have two acoustic guitar parts and I kind of hear them over here, right? And then there's a bass and I kind of hear the bass mostly coming from down here, right? And then that kick drum that I hear, is like below the bass, and then there's a point of it up here, right? Which is the kick. And when I listen to the snare drum, it kind of sounds like it's over here in the speakers. And then what you would do is you would do the top mapping, right? So that's the front mapping, and you would take those same things, those same colors, and you would say, okay, well, where's my vocal, right? The vocal sounds out in front of the speakers, right? So, oops, let me just kind of get over here to a level, right? So the vocal sounds out in front of the speakers towards me. And you could draw how big it sounds, right? That kick drum sounds like low, but it's actually behind the speakers a little bit, right? That bass sounds kind of a little bit more up front, right, from the top side view, right? Those acoustic guitars on the side, right, stick out of the speakers a little bit, right? Maybe there's like a keyboard part, right? A Fender Rhodes or something like that, and it sounds way in the back, right, behind the speakers. So what you're doing is you're kind of creating these 3D maps and kind of understanding where instrumentation is placed. So the limitations of the mix mapping sheet is that it only gives you left-right panning, but it doesn't give you any front back kind of characteristic. And because there's 3 dimensions to it, right? There's not just a front back, but there's also an up down, right? This is really critical. Okay, so this is the next stage of it, right? So, and your ears, at first this is going to be hard to hear, and the more that you actually start to do it and start to, put your intention on really understanding this, the faster that you're going to kind of go with this. And so what we get into is, with the 3D panning, okay, there are a whole variety of different elements that play into making it work, right? And so, so when you set things within the 3D sound stage, okay, and I'm going to do here, I'm going to go back here, and let's just talk about what happens, right, with sound, right? So when I actually have a sound, and let me just kind of draw one, right? So let's just say I have a sound here, okay? And what I'm going to work with is moving this around, right? So in other words, when I change the level of something, the level moves things front or back. And my pan moves things left or right. Okay, so my pan pot will move things to the left speaker, to the right speaker, and then my level will either move them forward or backward, right? So the level and panning is important because from the top 2D perspective, it's going to move things left, right, and front and back, right? So if you make something louder, it will stand out closer to you. If you make something lower in level, it will recede back into the speakers, right? Simple, right? So that's the 2D panning world, okay? And that's where we're basically going to start. So that's our levels and panning, and then the next thing is we'll get into phase and filters, right? And that we'll kind of get into. So that has to do with the solidity of the imaging. So we'll talk a bit about that. And I'm going to kind of move forward here just to kind of keep the course moving along. But this will give you the basic thing. The phase is really critically important because the phase, what that does, and the filters are as well. So I'll talk a little bit about filtering or subtractive EQ. The phase is really critical because whenever you have multiple microphones on the same instrument, they like drum kit, then each microphone will pick up every part of the drum kit, not just, it'll pick mostly the snare drum if that's what you have it pointed at, but it will also pick up hi-hat and kick drum and cymbals and other energy. But it will pick it up at a later time than the close mics do. And that delay creates a phase relationship. And that usually creates tonal colorations or cancellations. And there are ways that you can work with those individual mics to help make that phase relationship as good as it possibly can be. And just those subtle changes can solidify, right, the imaging of a snare drum and a kick drum and your cymbals. And that's really the stuff that we're going to talk about. The other part is filters. And filters, when I talk about filters, this is about what I call kind of taking out the garbage. Most instruments don't really need sub-frequencies. You have a guitar part, an electric guitar, right, big, heavy, thick electric guitar, right, will not have or not need, it will not need these sub-frequencies. And they do exist there as noise. And so what happens with those sub-frequencies is that when they are there, they take away from the instruments that do need those frequencies. So for example, if I need, let's just say, like I take that, filter that away from the guitars and the vocal and some of the other instrumentation, I filter off those low frequencies, those sub frequencies. That's going to allow me to hear the bass more clearly, because what I'm doing is I'm taking away noise that's not necessary or fundamental to the sound of those instruments. I'm taking away the noise, even if it's at this microscopically low level, that will cloud the clarity and definition of the bass and the kick drum where I need those frequencies, right? And that's really the whole concept of subtractive EQ, right? And working with subtractive EQ, right? So what we're doing is we're filtering off stuff from individual instruments that we don't need. And this is particularly important with acoustic instruments, right? And then I'll show you how that works, right? So that's the basic thing. So the session organization, and we'll get into some basic levels, panning, phase, and filters in week 2. And that concludes week 2. So let's move on.